Hello students, let us continue the discussion on understanding quadrilaterals. In the previous session, we were discussing different types of quadrilaterals. We have discussed kite. Now we have the third type of quadrilateral, which are parallelogram. If two pairs of opposite sides are parallel in a quadrilateral, then it is called parallelogram. Look at this parallelogram ABCD. In this parallelogram ABCD, we have the side AB, which is parallel to the side BC. The side BC is parallel to the side AD. We should know elements of parallelogram. Some terms related to the parallelogram, I am taking ABCD. First element is opposite sides. The pair of opposite sides are AB and DC, AD and BC. Here there are two pairs. The pair of opposite angles are angle A and angle C, angle B and angle D. So there are two pairs of opposite angles. The pair of adjacent sides are AB and BC, BC and DC, DC and AD, AB and AD. So there are four pairs of adjacent sides. Apart from the sides, we have adjacent angles also. The pair of adjacent angles are angle A and angle B, angle B and angle C, angle C and angle D, angle A and angle D. So there are four pairs of adjacent angles. With respect to these four elements of parallelogram, we have got properties of parallelogram. The first property is the opposite sides of a parallelogram are always equal. Here the side AB and CD, AD and BC are equal, along with they are parallel also. So we can say that the opposite sides of parallelogram are equal as well as parallel. The second property is the opposite angles of a parallelogram will always be equal measure, will always have equal measure. Here angle A and angle C are equal to each other. Angle B and angle D are equal to each other. The third property is related to diagonals. The two diagonals of parallelogram bisect each other. Look at the figure here. In ABCD parallelogram, the diagonals AC and BD, they bisect each other at point E. So we have AE is equal to EC and DE is equal to EB. Here you can see the marking DE and EB are equal, AE and EC are equal. The diagonals bisect each other. The fourth property is the pair of adjacent angles of a parallelogram will always be a supplementary angle. Look at the figure here. ABCD is a parallelogram. The adjacent angles measure when they are added up. Measure of angle A plus measure of angle B is 180 degree. So is the case with other adjacent angles also. The adjacent angles are supplementary. We are going to make use of this particular concept in finding the angles while solving the questions. Let us take a simple question and try answering that. The question here is, if the opposite angles of parallelogram are 3x plus 5 degree and 61 minus x degree, then calculate all the 4 angles of the parallelogram. We should recall that the opposite angles of the parallelogram are equal. So let me mention, as we know that the opposite angles are equal in parallelogram, so we can equate 3x plus 5 degree equal to 61 minus x degree. How do we solve this equation? We have to write variables to one side. We have 3x plus 5, which is equal to the numbers written on the other side, 61 minus 5. 5 is transposed, it becomes negative 5. Negative x on transposing, it becomes positive x. So on simplifying, we get the value of x as 14 degrees. Now substitute the value of x in the given angles. 3x plus 5 degree, which is equal to 3 times 14 plus 5, which is 47 degrees. 61 minus x degree, which is 61 minus 14, which is 47 degrees. Both the angles are 47 degrees as the opposite angles are equal. Now to find the other angles, let one of the adjacent angle be z. So 47 plus z will be equal to 180 degrees. So we get z as 180 minus 47, which is 133 degrees. The fourth angle will be 130 degrees, 33 degrees, as the opposite angles are equal. Hence we have found all the 4 angles, which are 47, 47, 133 and 133 degrees. Isn't it very simple? Let's move on with some special type of parallelograms. The first special type is called as a rhombus. If a parallelogram has all the 4 sides equal, then it is called as a rhombus. In this figure, ABCD is a parallelogram. In this parallelogram, if the side AB is equal to the side BC, which is equal to the side CD, which is equal to the side DE, then it becomes a rhombus. All the sides are equal to each other. Few properties of rhombus are: a rhombus has all the properties of the parallelogram as well as the kite. The special property is that its diagonals are perpendicular bisector of each other. Hence, AE will be equal to EC, DE will be equal to EB, and it makes 90 degree at the point of intersection. Or I can also say that the diagonals, they are perpendicular to each other. AC is perpendicular to the diagonal BD. At this juncture, I will be telling you, in a kite, one diagonal bisects the other, whereas in a rhombus, the diagonals bisect each other. The diagonal AC bisects BD, the diagonal BD bisects AC. So these parts will become equal. And the angle formed here is a right angle. We are going to make use of this particular property while solving question. The same thing which are there here as a property, you are going to learn it in class 9th with reasoning. You will be reasoning out why the diagonals are perpendicular bisectors, or you are going to prove that the diagonals are perpendicular bisectors. The next special type of parallelogram is a rectangle. A parallelogram with equal angles and opposite sides are equal is called as a rectangle. In the parallelogram ABCD, since all the angles are equal, each one will measure 90 degrees. Here the opposite sides, AB will be equal to DC, AD will be equal to BC, and all the angles measure, angle A is equal to angle B is equal to angle C is equal to angle D, which is 90 degree. Remember, in a parallelogram, if one of the angle is 90 degree, it becomes a rectangle. Few properties of rectangle are: opposite sides are parallel and equal, opposite angles are equal, adjacent angles, they are supplementary, the diagonals are equal in length, the diagonals do bisect each other. Each of the angles will measure 90 degrees. You must remember these properties, then only you will be able to differentiate a square from a rhombus, square from a rectangle. So now you can guess the next type of quadrilateral, that's a square. A rectangle with all the four sides equal, it's called as a square. Let me take a square. In this square, the side AB is equal to the side BC, which is equal to the side CD, which is equal to the side AD. All the sides are equal to each other. Look at the angles. Angles are equal to 90 degrees. From the previous figure, you can identify that this mark was missing in the previous figure. This is to indicate that the diagonals are making 90 degree, they are perpendicular to each other. That is a major difference between a square and a rectangle. Let us list out the properties of a square. All the four sides of the square are equal, opposite sides are parallel, diagonals are equal in length, diagonals are perpendicular bisector to each other, all the four angles are 90 degrees. Having learned all the properties and the basics, now we are in a position to solve few of the questions from exercise. So without wasting much time, let's take up the first exercise 3.1. The question here is, they have mentioned few of the figures. You need to classify them on the basis of simple curve, simple closed curve, polygon, convex polygon, concave polygon. Which are simple curve? Figure 1, Figure 5, Figure 2, Figure 6 and Figure 7, these are simple curve. Means there is no difficulty in drawing these figures. You can start from one particular point and end at the same point. Simple closed curve. All these figures which are simple curve, they are also simple closed curves. 1, 2, 5, 6 and 7. These are simple closed curve. Next, polygon. We have learned that a polygon must have line segments. Here, the figure 1 and figure 2, they are clearly made up of the line segments. They are the polygons. Convex polygon. Now we have identified the polygon. In these two polygons, which are convex, there is only one convex, that is figure 2. Concave, figure 1 is concave. Here you look at this particular figure, figure 8. This figure 8 is a complex curve. Means once you start from one particular point, you cannot end at the same point. It becomes very difficult. This figure 3 is also complex. The figure 4 is also complex. You cannot start from one particular point and end at the same point without lifting hand. Such type of figures are not simple. These 3, 4 and 8 are not simple curve or a simple closed figure. Question number 2. How many diagonals does each of the following have? A convex quadrilateral. A quadrilateral will be having 4 sides. You make use of this formula n into n minus 3 by 2. If 4 is the number of sides, 4 times of 4 minus 3 by 2, which will be equal to 2. 2 diagonals are possible. For a regular hexagon, there will be 6 sides. 6 into 6 minus 3 by 2, which is 3 times 9. A triangle, 3 into 3 minus 3 by 2, which is 3 by 2 times 0, which is 0, no diagonal. Let's draw. Look at this figure. It's a convex quadrilateral. In this, the number of diagonals are 2. Look at this figure. It has got 6 sides. Let me name the sides 1, 2, 3, 4, 5, 6. Now count the number of diagonals. So in a regular hexagon, there will be 9 diagonals. In a triangle, there is no non-consecutive vertex, so no diagonal formed, or we can say number of diagonals is 0. Let's take up one more question. What is the sum of the measure of the angles of a convex quadrilateral? Will this property hold if the quadrilateral is not convex? Let me take a convex quadrilateral ABCD. From the figure, we infer that quadrilateral ABCD is formed by 2 triangles. They are the triangle ADC and the triangle ABC. You can see here 2 triangles are there. Since we know that the sum of the angles of a triangle, interior angles of a triangle, is 180 degrees, the sum of the measure of angles is 180 plus 180, which is 360 degrees. Now let's make a concave quadrilateral. This is a concave quadrilateral. In this concave quadrilateral, if I consider a diagonal here, again there are 2 triangles formed. They are triangles ABC and triangle BCD. Now in the triangle ABC we have angle 1 plus angle 2 plus angle 3 is 180 degrees. Same is the case with triangle BCD. Now if you add these all angles, we get the sum as 360 degrees. Hence, the sum of the interior angles is 360 degrees in both convex and concave quadrilateral, which is not convex, is a concave quadrilateral. With this question, I'll end today's session. We shall take a few more questions in the next session. Thank you.